Okay, unfortunately my son is sick and my wife is out of town, so I can't be here with you guys today. But here's something you can expect, a calculation FRQ. There'll be one on the upcoming test, and there's also guaranteed to be one on the AP test. So here are Mr. G's steps to success. By the way, don't watch this until after you have toiled and troubled and tried. You need to try first and then take a look at the answer. So, step 1, take a deep breath and tell yourself you've got this. Be confident. Okay, 2, while reading the question, underline given numbers and circle the units. So let's go through and let's take a look here. A large natural-fired electrical power facility produces 15 million kilowatt hours of electricity each day it operates. The power plant requires an input of 13,000 BTUs to produce 1 kilowatt hour of electricity, and it says 1 cubic foot of natural gas supplies 1,000 BTUs of heat energy. All right, next part, it says write out the numbers with the units. It helps to visually see what you're working with. So let's see what we got. So 15 million, 3, 4, 5, 6 kilowatt hours per day. That's one number. And then we've got this 13,000 BTUs. So 13,000 BTUs of heat to produce 1 kilowatt hour. So per kilowatt hour. The last thing it gives us is it gives us 1 cubic foot of natural gas is 1,000 BTUs. So 1 cubic foot per 1,000 BTUs. So it just gives us those 3 numbers to work with. All right. So next thing we need to do is determine the unit the answer needs to be in and write it on the far right. So if we look here, the BTUs needed to generate the electricity produced by the power plant in 24 hours. So BTUs needed to generate 24 hours. So the answer we want is in BTUs per day. Instead of 24 hours, we can just write it as day. Okay. Next step, number 5. Use the question to find a starting point. If you can't figure out one, use something that has at least part of the same unit you want in your answer. So here, let's take a look. What do we have to use? We know that we want BTUs per day. If I look, I just see BTUs on top, so let's start there. So if I start with 13,000 BTUs per day. All right. Oh, sorry, that's not per day. Getting ahead of myself. That says BTUs per kilowatt hour. So, number 6, choose what number you want to use next based on cross-canceling units. What units do you want on top? What units do you want on the bottom? All right, so let's look here. I know that I want BTUs on the top. That's great. So now I know that I want days on the bottom. What do I have? That number has days on the bottom. And look, it happens to have kilowatt hours on the top. So if I use that 15, 1, 2, 3, 4, 5, 6 kilowatt hours per day, I can now cross-cancel my kilowatt hours, and that's the unit I want, BTUs per day. BTUs per day. So you keep doing that. This one was a little bit easy, but you keep doing that until all the units match up with the units you want in the answer. Okay, and then the last thing you need to do is you got to convert it to scientific notation, because it really does make it quite a bit easier, and then do the math. One reason why I wanted you to do this first before you went to scientific notation is if you can put it in this scenario and then get an answer there, that's worth 1 point because it's the correct setup. If you get the correct answer, that's worth the 2nd point, but if you at least get this far, that's worth 1 point. So let's do the math. So this, if we do it into scientific notation, 13 times 10 to the 1, 2, 3 BTUs per kilowatt hours times 15 times 10 to the 3, 6 kilowatt hours per day. And once again, kilowatt hours cross cancel, and that's equal to 15 times 13. You just do the math. and you get 195 times 10 to the 3 times 10 to the 6. In this case, the exponents add when you multiply in scientific notation. So that's times 10 to the 9 BTU per day. And that's the answer to part 1, and that's how you get the answer. Once again, 2 points. 1 point for setup, 1 point for the correct answer. For B, let's see. We already wrote out the units before and what we have. So let's see. Let's start off with what we want our answer in. That's number 4 up top. So we want cubic feet of natural gas consumed each hour. So we want our answer in, I'll just leave that off for now, cubic foot per hour. So we need a place to start. I know if I look up here in the top, I've got cubic feet over there, and that's on top, so let's just start there. So 1 cubic foot per 1,000 BTU. So now I've got cubic feet on top, and I know I don't want BTUs on the bottom. So I know the next thing I need to do is get rid of BTUs, because once again, I've got what I want on top, but I want hours on the bottom. And if you look up here, it gives you BTUs there. You could use that number, but I'm going to give you a hint. On these questions, they love to use what you've already found in A. So if I look in A, there's BTUs on the top again. So I can just use that number. 195 times 10 to the 9 BTUs per day. And now I cross cancel my BTUs. They're gone. And now I've still got cubic feet on top, but now I've got days on the bottom. And now you'll notice it doesn't give, you'll notice that you could use this number, but you actually already used that number in this equation. So all you have to do here is get from hours to days, and you can figure that out because you've been doing this ever since you were in the 4th or the 1st grade. So you do 1 day is 24 hours. Your days go away, and if you look, now I have the units I want. Cubic feet per 24 per hour. And then I've just got to set up my math. This is 1 times 10 to the 3, and that's 1. So if you do this, that's 1 times 10 to the 3. When you have an exponent in scientific notation over another exponent, you subtract. So that's going to be times 10 to the 6th. And then you take what's in front, that's going to be 195, and you divide it by 24. And if you do 195 divided by 24, you get, what's that, 8.125. So you get 8.125 times 10 to the 6th cubic feet of natural gas per hour. Okay, there comes a time in most of these where you just have to figure something out. It's going to be a curveball. You're just going to have to use what you know to figure it out. That's this part. So it wants cubic feet of carbon dioxide released by the power plant each day. So the unit we want is cubic feet of CO2 per day. So that's the part that we got to figure out. That's the unit that we want. Assume that the methane, so now it's telling us that the natural gas is methane, combusts with oxygen to produce only carbon dioxide and water vapor, and that the pressures and temperatures are kept constant. This is where you have to use that chemistry knowledge that just pops into your head and you said, wait a minute, if pressures and temperatures are kept constant, this sounds like a chemical equation that we can just set up and balance. So, methane, CH4, combusts with oxygen to produce carbon dioxide and water vapor. So since the temperatures and the pressures are kept constant, all we have to do is we have to balance this. So let's just go 1 CH4 here, there's my 1C, that's H4. So 2 H2s would give you my H4s, but that puts 2 O2 over here, and there's 1 O2 over there. So that's O2 plus O2, so that's O4. So I need 2 of those. There we go. So basically what I just figured out is that for every CH4 that's produced, it produces 1 CO2. The equation showed me that. That's why I had to balance it just to make sure. Okay, now if you go back to what gave us last time, what we figured out in B, because it says cubic feet of carbon dioxide each day. So we found out in part B, remember I told you that they like you to use the ones previously, we found 8.125 times 10 to the 6 cubic feet per hour. We found that last time. We know that we want it in cubic feet per day. This is cubic feet, and it told us that it was methane. So cubic feet of methane per hour. We know we want it per day. So we get rid of our hours, 24 hours per day. So there goes our hours. And now we've got cubic feet of methane per day. But we don't want cubic feet of methane. We want cubic feet of CO2. So we times that by what we figured out up here. We know it's 1 cubic foot of CO2 per 1 cubic foot of methane. My cubic foot of methane go away, and now my unit I have left is cubic feet of CO2 per day, which is exactly what we want. And this number is a number that we had already found before. That is the same number we found in the beginning. It's 195 times 10 to the 9 cubic feet of CO2 per day. Yeah, this one is tricky. You just got to remember that, and you've got to use your logic to step through it.